This is the Optim Update. I'm Bogdan Kristey, and today I have two founders who are building robots for some of the most demanding industrial environments on the planet: construction, shipbuilding, and steel fabrication. There's a lot of noise right now about humanoid robots taking over these industries. Gary Chen and Conley Oster, co-founders of Raise Robotics, have a much more nuanced view, and they have actually deployed robots in the field to back it up. Without further ado, here's my conversation with Gary and Conley. Welcome. So happy to have you guys here. I think I've known you guys for 5-6 years now. This is awesome. Welcome.
Thank you.
Thank you. It's nice to be here.
Absolutely. Let's start with some quick intros. Gary, why don't you give me a little bit about Raise Robotics in one sentence, and then tell me a little bit about your background and what pulled you into this problem, and then we'll go to Conley right after that.
Yeah, one sentence, I would say that, at Raise Robotics, we build robots to help people build big things. It's probably the simplest way to put it. And yeah, before Raise, I worked on robots, I guess like pretty much all my life now. I remember when I started in elementary school, when I watched a cartoon, I asked my dad, hey, like I want to build this. Can you please like help me like figure out how to do it? And he bought me a bunch of clay and we put it together. I was like, but it doesn't move. Like I want it to move. And so I begged him enough and he finally bought me a Mindstorms kit. And I guess that's how I got started in robots. But since then, just working on different types of robots. Most recently, before this, working at Waymo, working on perception and kind of simulation type problems. And now at Raise, I work a lot on the software and I work a lot with CTO on the hardware. And we build basically these mobile manipulators that go out on construction sites, steel factories, very soon shipyards to do tasks where we think people really shouldn't be working.
Awesome. So I've known you for 6 years. I did not know that story. That's why I love doing this podcast. It's so cool. Let's see, Conley, what am I going to learn about you that I don't know yet?
I don't really have any fun facts on this. I guess what pulled us into this problem, or what pulled me into this problem, I would say just the fact that it could be done and it could actually be done. I find it fascinating. So, I mean, before this was working in the heavy equipment industry and the crane and rigging space. And there were a lot of, I guess, new things to hit the construction industry while I was in it. And I would say by and large, nothing worked. And, it wasn't until Gary and I started talking, and I was very hesitant when we started talking that, anything he did in his past life could be applicable to construction, just because I was very familiar how challenging it was to get a crane on a project. I could only imagine how challenging it would be to sell someone on a robot and get that deployed. But
Yes.
we did about a year together of just, I guess, kind of sussing each other out and then making him talk to my customers, putting together simulations and seeing what would stick. The more I learned and the more, Gary taught me about kind of what's possible. I mean, leveraging a lot of the lessons learned in AV, it made me realize, there's a huge market application for this. And it's not that the technology has always existed. Like, this is something that is new and it's a ripe market to get into.
Got it. Awesome. Well, let me start us off by saying that as an investor, I see an enormous amount of capital flowing into robotics right now. It's finally, a hot space. And most of the conversation revolves around humanoid form factors. So robots that look like people, designed to do human jobs in a world kind of built for humans. Construction and heavy industry are two of the most commonly cited targets. But what I want to explore today is whether that framing is quote unquote actually right. And I think you two have a more grounded view of that based on my conversations with you guys over the past few years. So let's get into that. Let me start us off by asking what the work actually looks like. So not the output, not the finished building or the finished ship or the day-to-day process, but actually, what is happening on the ground. I think a lot of people who are excited about construction automation have never spent time on a job site. So I think that gap matters a lot. So maybe we start with you, Conley. Paint a picture for someone who has never been on a heavy industrial job site. I imagine you with a hard hat, steel toe boots. You'll go in, you know how to talk to these guys. What does the actual work look like? The environment, the physical demands. What a shift actually feels like for somebody doing this day to day.
Yeah. I mean, before going into industry, I mean, I worked at a couple messy factories, and I always thought, if I worked at a bad factory, I would assume that a construction site's going to be, almost the exact same, where there's some disarray, but there's still some resemblance of structure throughout. But when you get on site in construction, that's like, it's not the reality. I mean, everyone has a plan, but you got to work with a lot of variability to execute that plan at hand. I think if you were to just, put on a hard hat and walk into a job site, if you were to do, commercial construction, shipbuilding, or industrial fabrication, you pretty much see the same thing. You walk in that door and it's immediate sensory overload. And you feel like it's just chaos that's surrounding you. You got big equipment moving all over. You got extremely loud noises, bright lights. If you're not focused, it's easy to kind of get caught up in things. And I think, coming into industry, the most surprising aspect for me is, you know, everyone is super focused and super fixated on getting their work done, and it's kind of just your job to stay out of the way. Just don't get caught up in it. Don't get run over by a backhoe. Listen, keep your head on a swivel, just stay out of the way. Chaotic. I mean, it's not a factory, but there is still structure and there is still a process. You just got to be on site to really understand what's going on.
Yeah, so you spent some time on sites, but I'm wondering, Gary, what surprised you the first time you spent real time on a job site versus what you were expecting?
I think for me, it was actually the weather, probably. Working at AVs, like you kind of work a little outdoors in garages and stuff, but you're not really like outdoors for like 8 to 10 hours a day. And I think that was definitely one of the biggest things. Working on a robot while you're in the sun, getting baked the whole day. We've had some job sites where like it was like, in Dallas in the summer, it was like 100 degrees and the hoist was broken down. So we're walking like 12 flights of stairs like 2 or 3 times a day. And this might be TMI, but those days I was just like, I would have to try to hold my pee in because every time I had to go pee, I would have to walk another 12 flights of stairs. So I was trying to keep my bathroom breaks down to like as low as possible. So I was like, definitely the environment is challenging. And it's something I think like even coming from like manufacturing settings, right? Like it's like I've worked in like workshops, like drilling holes. It's very different once you do those same activities out on sites. It takes a toll on your body.
All right. So, maybe that explains why there's a labor shortage in construction and that nobody wants to do this work anymore, right? So, Gary, let's stay on with you. What is actually going on there?
Yeah, I mean, it's kind of an interesting, I think, dynamic, and it's something that definitely that I've personally learned more about working in industry. The labor shortage is definitely there, but it's not as, I would say, uniform as I would have expected. It's not that you can't find people to do jobs at all. I would say, like with any market, it's the same thing, right? Supply and demand. If you pay people enough to do the work, you'll be able to get good people to do it. But that is one thing that is, I think, starting to create a lot of problems. Just prices go up, it gets more and more expensive to build. And
Yep.
especially when it comes to skilled labor, there are certain roles where what we're seeing is a lot of people have retired. And whenever I visit customers, they keep telling us the same thing. They're like, hey, we have this really great person who's like basically keeping the company running, 60 years old, and like, once they're out of the door to retirement. And the new people, like who are like the 20, 30-year olds, they're getting trained up and not nearly fast enough. And we said there's going to be this gap in our company where the old people are going to retire, the new people
Yep.
still aren't up to speed, and we just don't know how we're going to keep things running. So and like it's kind of surprising because like it's not just one customer in one industry; it's
Yep.
every customer we've talked to across all the industries we've worked in, not just construction, but also like shipbuilding, manufacturing. It's just such a prevailing problem these days.
Got it. Got it. And then, in previous conversations when we were chatting, we were looking at how the work actually breaks people. So do you have like any comments on that by any chance? Like what's the reaction there? Walk me through the most common causes of injury and death and all those things. I think there's a big push now towards ladder-free work on commercial job sites. So I wonder what that means in practice. Um, just some thoughts there.
Yeah. I mean, like you said, big push away from ladders and biggest hazards that are present on commercial job sites and just heavy industry in general. Fall from heights, crushed by incidents, slip trips and falls are also another huge part of it. It's backbreaking work at the end of the day. And I think the reality is for a lot of these scopes of work where you are, in these hazardous environments, whether it be on the leading edge of a building or working from height or doing work overhead, many of these jobs, like if there was a better way to do it, people would prefer not to do it. If they could oversee something else doing it, they would be more than willing to adopt these solutions. I think that's kind of the challenge right now is we're just starting to see technology enter and we're starting to see, I would say, the tail end of the marketing campaigns that have been running for like the last 2.5, 3 years for most automation companies like actually starting to hit their target audience in the field. So we're starting to see people, bending and adopting to, you know, getting
Yep.
things done better with less hazards present and, enabling safety for everyone at the end of the day.
One thing that I think that also surprised me that I think a lot of people don't realize is just how very simple tasks can be very hard once you start doing them for like hours a day. Because one thing like even for me, like not even working on the site, but even just working on our robots, sometimes we had to be like kneeling on the floor, like assembling components or bending over. And it's like if you do that for like, once or twice, like if you're assembling IKEA furniture at home, it's not that bad, right? You do it like every couple of years when you move to a new spot or you're renovating. But once you're doing that work like every single day for like
Yep.
8 hours, like building robots in, working on site, like you have to reach overhead to drill holes, it adds up very fast and people get tired. And, we were talking with like a person from leadership with the union and he was
Mm.
saying like, for like 10, 20 years of his life, he just kept working and he just never had time to recover. Like you go to work, you work 8 hours, you go home, you sleep. Next day, you're still sore. You keep working, you keep working. And he's
Yeah.
even though he's not in the field anymore, he feels like the last couple of years he's still been recovering, even now that he's in more of a management position. It's just pretty crazy how things add up.
Yeah, totally. Conley, we were speaking, on the pre-call about the amount of training required for like a 1 hour long meeting on the job site. Can you get us up to speed on that? Like, what's the deal there?
Yeah, I think this is just kind of a soft cost that no one really thinks about. Being in crane and rigging, I had to go out to every type of project in construction, utility, you name it, I've seen it. But it really opens your eyes to how much I would say pre-qual and just admin is associated to completing this work. And even for me, just to meet people to talk about doing this work. So, I mean, there were projects at national labs and then also some utility projects where just for me to facilitate a meeting and then doing some initial field engineering, I would have to go through a 40-hour safety certification course.
Wow, one
And
full week.
yes, one full week, 3 days of oversight on a project or a similar project before deployment to the actual project to talk to someone about the project. That's a lot of coin. At the time, I didn't think about it, but now that I'm facilitating trainings for some of our team members, like that is a ton of costs. The overhead that comes with it is pretty insane. Same goes if you're actually working on any of those environments, like the PPE requirements to actually deploy in those. And if you're doing anything utility, having the proper FR gear, or if you're doing, any abatement, having your ventilation, there's so much associated overhead with doing hazardous work. It's kind of crazy to think about.
Yeah. Quick, quick answer from both of you without thinking too much. Let's go to Gary first. What's the single image that comes to mind when you think about a task that the human body was just not built for?
Yeah, I actually have one that it always sticks in my mind. When I was on a site, like I think that was also in Texas, and I see this plumber. He's literally climbed up a pipe he just installed, and he's standing on like a little flange, and then he's tiptoeing on that to try to reach the top flange to screw it in and tighten it. And that's just like, yes, like human body can do it, like he's doing it, but that's clearly not what you want to be doing every single day. And it's very easy to fall and he wasn't tied off. He like if that surface was just wet, like some moisture or rain, slipped really easily and he could have fallen a couple feet, hit his
Oh my
head.
God.
It's just that image always sticks in my mind.
Oh my God. Conley, any war stories you have to share with us?
Yeah, I would say anytime there's like a visual scale mismatch, I always find that very funny to look at. Like if we were doing a bridge girder installation with one of the previous companies, just tiny people trying to manipulate, a 300,000 pound beam into position within, millimeters of accuracy, that it just blows my mind. You're putting yourself in a massive, massive hazard to get struck by something.
Oh my gosh. All right, so we have this picture of work that's genuinely hostile to the human body. And I think we have a labor market that pretty much reflects that, right? So the obvious question now becomes, what does the right answer look like? And this is where I think you two have a take, because this is a little bit more nuanced than what gets said publicly about robotics, I think. So we've been chatting, outside of this podcast, but because the dominant narrative right now is humanoids, I would like to dig a little bit into what you think, if you think that framing is incomplete, at least for this part of the market.
Yeah. I mean, I think like from my perspective, I love humanoids. They're very cool robots. Even when we got started, we were considering like, for some of these applications, maybe we should use a humanoid. But the problem, like from a technical perspective that I always saw with our applications at least, was just that the human form factor just wasn't big enough, surprisingly. It was just literally people are a little too small. Like, if you need to reach
Interesting.
around a column and you're stuck behind something and you're kind of reaching over, people's arms just aren't long enough and they have to like do like weird things to get around there. A lot of the applications we also had customers ask us for is just like lifting really heavy objects. And yes, you can get pretty decent payloads with a robot, but a lot of times you're trying to lift like hundreds of pounds or thousands of pounds. And that's also why we build lifting machines like cranes, because the human body just, we literally cannot lift a steel beam by hand. You need
Yeah.
equipment to do it. So
I
there's a
think
lot of
that's
these
like
things.
the
Yeah.
the
Go ahead,
best
Connie.
the best way to like see which applications we take on. We're looking at applications where human physiology is the limiting factor.
Mm,
Us adopting a human form factor does not enable anything else. We're, dealing with the exact same constraints at the end of the day. If we're doing long reach or high overhead work, putting a humanoid in a man basket is just replacing the human with a human
yeah.
looking machine. It's not
Yeah.
solved.
Yeah. So maybe that reminds me of like the self-driving car parallel, right? Because I think it's the clearest kind of comparison here. I would say we didn't solve autonomous driving by putting a robot in the driver's seat of a taxi, right? We made the car itself the robot. So why can't we do this for industrial automation, or will there be some similar change instead? Gary, over to you for this one.
Yeah, I think with self-driving, the interesting thing is like in some essence, when you're looking at that problem, the physical robot was already built, right? The car was
Yeah.
a physical robot. And what you needed to do was add some additional sensing on top of it, and then maybe make some controls adjustments for like drive-by-wire. But primarily you had the hardware ready, and it was just about replacing the person who was driving the vehicle. And so that was primarily a software challenge. But when
Mm,
you take a look at industrial automation, and a lot of these spaces where people are working today, there's not really like a physical form factor for a robot that can be a direct drop in. The robot needs to actually be built. And I think that, a lot of people are assuming that you can just take a humanoid and drop it exactly where that person works today. But I
yeah.
think the biggest challenge that we see is that the processes themselves are like when people are working on these sites, it's actually the person's physical body that leads to a lot of the issues with the process, like making mistakes.
Mm,
That's actually where a lot of the issues stem from. It's just people aren't physically capable. And so then when it comes to like how do you get a robot into spaces, you kind of do have to rethink what does the
mm.
physical form factor of the robot look like that should actually be doing these tasks. And then you have to build that robot and then put the software and the brain that controls that robot on it to go out and work in the real world.
Got it. All right. Here's a quick question for Conley. If somebody built a 5-story humanoid with full human dexterity, is that a good answer for some of your use cases, or does the problem go deeper than scale itself?
It definitely goes deeper than scale as much as I would absolutely love that to happen. And it is something that we've talked about before. It doesn't solve all of the problems. I think when you think conceptually, does it solve the problem? Yes, it does because of the scale. We draw parallels too to if you had a massive gantry that just spanned the entire job site or your entire fabrication facility. I mean, it solves a lot of the discrete positioning issues that pop up with these very large
Mm,
objects because you're able to encapsulate that entire object. And very similar to, what you'd see in an automotive facility and robots just working on smaller objects. It's just not the most practical approach if your means and methods to deliver said object or project cost exponentially more than what you're actually delivering. Logistically, quite challenging to think about. Kind of the approach that we've taken in I would say this specific problem, it's like, we can recreate that entire gantry system and bound all of this through,
mm,
I would say, distributed metrology at the end of the day. So having a
mm,
localized robot with sensors on board, establishing a software gantry per se, instead of having to
mm.
have this massive, physical gantry.
Yeah. Yeah. I think Raise Robotics sits kind of in an interesting position. Not truly general purpose, but not really single purpose either. So how do you guys describe where you actually fit? Which one of you wants to take this one first?
Yeah, I can take a stab at it.
All right.
I mean, I think like actually I would take a less like technical approach to this answer and more like just looking at the industry itself, right? When you take a look at like how work is structured in these heavy industries today, like even the people who do the work today aren't really general purpose. Like that's why you have trades, right? You have people who go through years, decades learning to be like a welder or a fitter or a painter. And that's all they do every single day. Like, and yes, like the people, us, were considered general purpose, but when we actually go and work in like commercial settings, like we try to specialize because that allows us to do work at a much higher quality than we would try to do everything at once. It allows processes with multiple people working together to be a lot more streamlined. And that's kind of how we take a look at, our
Uh,
industrial automation. We create robots that are general purpose in the sense that they can handle multiple environments, but we don't need them to do every single task in the world. We want to automate these specific buckets where, the industry has already defined this task of drawing a line, drilling a hole, painting a surface has enormous value for multiple customers in that segment. And if we can automate those tasks, then there's a really good opportunity for us to really scale out a large number of robots out in the world.
I'm thinking single purpose industrial robots have been around for so long, decades, right? So, you have drill presses, CNC machines, spray systems. What can Raise do that those can't? And I'm thinking, what do you think when you're thinking kind of platform as a service? That's something that VCs love to use. So how do you think about putting it all together? Maybe we start with Conley this time.
Yeah, I mean, you can tidy up like all of these static pieces of tooling, with the drill press, and lathe, CNC. You can take any hand tool pretty much with our system and then integrate it into a localized delivery. So if you have quality critical work that needs to be completed at a certain location, we can complete that with the platform. So the platform's enabling high accuracy, unbounded work in any environment at the end of the day.
I think I would go back to the point Colleen made on the earlier question, right? It's like with traditional automation, what you have to do is you have to literally enclose the problem in like a space where you control it, right? And with a CNC, it's like that build volume. It's, at most probably like a meter by a meter by a meter. We have those really huge ones, maybe like 10 meters. And then if you look at like slightly above that, that would be something like a assembly line in an automotive facility, right? The assembly line itself is the encapsulation of like this problem. And so you can have multiple robots, but you're always in this controlled space. But that really starts to break down once you get to either very boutique components or very large components where you can't have that repeatability. You need to kind of have a much more flexible solution. At that point, in my opinion, at least, and I think in a lot of like more, I guess, cutting edge startups nowadays, it's that you have to kind of invert this approach where you can't have a robot that encapsulates the problem, but you need a robot that can work around the existing problem, the existing environment. And that leads to a lot more opportunities in automating tasks that technology in traditional classical factory automation can't accomplish.
Yeah, here's what I find fascinating. When you describe what the robots actually do, and we've talked about this in the past, like drawing lines, drilling, spraying, it sounds almost super simple on the surface, but you're charging a lot of money for it, right? So help me understand why these tasks are so much harder than they look, and how can you have that arbitrage?
Yeah,
Conley,
I'll
start us
start.
off?
I mean, just kind of talking about Gary's previous point, like people make a living doing each of these discrete items, like an entire career of drawing a line. And, I think it's a disservice to oversimplify it, quite honestly, to tradespeople, because this is their livelihood. Like this is an entire lifetime spent in improving this one specific deliverable. And there's hundreds of thousands of each of these employees doing each of these specific deliverables. And I don't know, it gets me kind of worked up. But I'll say, unless you've done it, you're not going to understand the inherent challenge. They're very easy to do. I mean, it's easy for anyone to pick up a paintbrush and then paint a painting. Did you actually do it correctly or well? No, not necessarily. Like when you start moving from I would say the theoretical side to the, delivery side and execution, getting, an entire building facade laid out to a 16th of an inch is extremely challenging. It's not something you can do just using a tape measure. Like, you actually have to have conscious thought. You have to have good fundamental understandings of geometry. You have to know how to do multiple things outside of that discrete task. Have to know how to process your CAD inputs, how to check if your CAD inputs are correct, how to interface with your PM. Like, there are so many soft skills aside from what is specifically being asked of that person to deliver on a project that all accumulate into the success or failure of that specific delivery. And we see it time and time again where something so simple as drawing a line ends up fucking up everything. Excuse me, ends up messing up everything.
Yeah. Yeah, and I mean, on the technology side, we see that exact same thing, right? It's like you have a robot where you're kind of just trying to get it to do like a very simple task, but
Uh,
what you're actually doing, like on a more like organizational level, like that we're starting to see now as we get more robots out in the field, is that you're using the machines as essentially a bridge between the design and the physical world. And that's what these tradespeople have been doing for like the last, or I mean, hundreds, thousands of years, is that
uh,
they kind of just do very simple things with their hands, like, doing these simple tasks over and over again. But what they're really doing when in those actions is they're taking the design that, this team has worked on and that they want to implement, and they're trying to figure out intellectually, how do I move my body to get that design to become real in the world? And that's actually a very, very complex process. And that's something that as we're building our robots and we're collecting data and working with our
uh,
customers, we're trying to figure out how to replace really these manual processes with and recreate all of that intelligence in the machines so that we can now have the robots take over this translation process.
I think it's a very important item right there. It's, as the labor shortage continues, you're losing a lot of tribal knowledge. Like, you're losing the human LLM that's been created to deliver these projects. So you need to engage with the people that are, the holders of this LLM. So that's, I mean, we've partnered with America's largest labor union for that, specific reason, where it's like there has to be this transition from what is tribal knowledge to digitized tribal knowledge that we can leverage for better deliveries. Like, there are inherent ways that they've learned to do things and deliver projects that are going to supersede what a roboticist would be able to, come up with from a very, I would say, analog approach to how a project needs to be delivered. Like, if you're looking at painting specifically, like looking at the perfect toolpath for painting, it's not going to be analog, we're spraying perfectly perpendicular to the surface, going at a, this perfect trajectory. Like, there's elements of art within all of these project deliveries, and those
uh.
are all things that you have to tease out of the people actually doing the job now. Now, how do you overcome these obstacles that you've faced for the last 30 years? And you can bake that into the system as well.
Yeah, turns out operating in the real world is not as easy as operating in the digital world, I guess.
No, we wish it
Unfortunately
was.
So on that topic, I'm an investor. I'm genuinely super excited about the robotics space. I want to get smarter myself about how to evaluate robotics companies. Since I have you guys on right now and I can, pick your brains, I would love to ask you both to be super honest with me and without kind of bashing any names in particular or anyone in particular. Just help me understand at a high level where investors like me tend to kind of miss things or ask the wrong questions. So maybe we can start with, like, what do investors generally get wrong about robotics? What are the biggest misconceptions that you run into when you're in a fundraising conversation, for example?
yeah,
Yeah,
I
you
think I think it's hard to answer that generally for me, but I
Uh,
think the thing I always go back to is like kind of what I saw with self-driving back
uh,
around 10 years ago. Back then, like around 2015, a little bit before that, like it was really, really hot. Or maybe like a little after 2015. But it was like really hot, right? Like there were billions of dollars, like 10 hundreds of billions of dollars getting poured into this space with like really I would say like a little unrealistic expectations of how fast technology was going to develop. And then like it kind of all came crashing down right around COVID time. A lot of companies ended up going under. A lot of
yeah.
companies that got acquired, it took them longer to develop the technology than their acquirers expected. And so
Uh,
I think that is one of the biggest things. It's really easy to make like demos and that's a lot of the stuff that we are seeing these days. It's not really production work. It's like initial entries into the market. But at the end, but it does take time to really truly get all these kinks worked out to get systems
Yeah.
to that reliably. But at the end of the day, like the other thing I will mention is like, self-driving does work, right? Like we have Waymos everywhere.
Yeah.
It's still a company like I love. Like I always tell my friends, anybody busy, I'm like, hey, have you tried Waymo? Yeah, you guys should take one. And I think like even this way of a technology with some of the, new sensors, new actuators,
Yeah.
and of course like the AI and the machine learning techniques, there is something new here. There's a lot of opportunity. And I think it's just a matter of being patient enough to see it through and for the technology to work, the people who are working on technology to work out the kinks to commercialize it, and it will get there.
Yeah. Conley, any thoughts here?
Yeah, I would say investors over-indexing on the fact that robots, or the opinion that robots should only be, doing one thing. That if you do more than one thing, you're going
Yeah.
to spread yourselves too thin. You're going to do multiple things poorly instead of doing one thing well. I think 5, 10 years ago, I'd probably agree with the statement more, but we do have the means and methods now to deliver new applications on top of platforms more quickly than we ever have before, and to train models in ways that we've never trained them before, to build in more robustness into a quicker project delivery, life cycle. I'd say that's one of my biggest pushbacks. And then also looking at it from the customer's perspective, if you're trying to sell a specialized tool, it's a lot harder than selling a general purpose tool, especially if we're
Mm.
looking at heavy industrial equipment. If I could get a Bobcat instead of a wheelbarrow, I'm going to get the Bobcat. Like if there are ways that I can get
Mm.
more out of that equipment,
Mm.
in ways that I can utilize the equipment
Mm.
across more types of projects with more types of customers, looking at that piece of equipment as a distributor, it becomes much more attractive. And if I'm looking at it as a customer, it's something that I feel as though I'm going to get my money out of. It's not going to be tied to a singular aspect that I might have overestimated how much I'm actually going to use. And after, going into year 2 on my lease agreement, I realize, I'm not seeing the utilization that I once thought I was. Coming from equipment rental before this, like I can say confidently, those specialized tools and specialized pieces of equipment, they're not getting the utilization rates that you think you're going to get. And we
Mm.
offloaded a lot of them because of that, because you can't get them out the way that you thought you could.
Interesting. So I guess with the new technologies nowadays, if you go out in the field and you have a customer that's asking you, "Hey, can you do this other thing for me?" You can probably train the robot in a couple of days versus what it would be 3 months before, right? So maybe Gary, any thoughts on that? Like, what's the state of the art there?
Yeah, I mean, I think like this is a harder problem to answer. I think than it shares on the surface because yes, like nowadays, like with some of like the new imitation learning policies, you really can get policies trained pretty quickly. Like a simple task, like 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 picking something up and placing it, or even like folding laundry, you can get a decent model trained with like a couple hundred demonstrations, and that could be just like a week's worth of data collection.
Mhm.
But once you start changing like the conditions of the, I guess, is it the domain of the problem? Like, let's say like instead of folding laundry just on this specific table, you're folding laundry across like, 20 different locations, or you're folding laundry on the edge of a building. This starts to create a lot more challenges. Once at that point, I would say like once you start kind of changing the environment a lot, the technology like gets a lot harder. And that's one of the biggest challenges we deal with. And that's one area where we spend a lot of work is on how to kind of bridge these two areas where you can get really great task level generalizability, but not necessarily environmental level generalizability just with a single end-to-end model. And making those two work together is definitely one of
Mm.
the challenges we focused on.
Yeah, no, that's interesting. I'm wondering, you guys spend so much time on job sites, actual sites out there in construction and manufacturing. I wonder, in your view, what does a job site look like in 2030, 2035? Like not just for Raise Robotics, but for heavy industrial work broadly. Like what changes, what stays the same? Any one of you, feel free to pick this one up.
I'll kick us off. I think the two big themes that I foresee in 2030, better process insights. So customers getting better data of how they're actually delivering and the quality at which they're delivering across all of these industries. So better, I would say, inspection tools, whether it be robotics or any handhelds or IoT devices. And then I would say robots have predominantly offset humans from servicing the high hazard work. So you're not seeing people on lift platforms like you once did. You're not seeing people spraying, caustic aerosols. You're not seeing people doing, I would say, also hyper quality critical work.
Mm.
It's going to be a lot easier to trace back a problem through an algorithm than it is to ask a human, why is it messed up at the end of the day? So I think anything that's going to be dealing with, I would say, just hazard mitigation at the end of the day, or mitigated liability. Those are kind of the two themes where I see autonomy and robotics really playing a big part in the next, 5 years.
Yeah,
Yeah.
Gary?
Yeah, I think I would actually touch more on like the technology implementation side. Like when we first started the company, and there's even now, like there's kind of this stereotype about heavy industrials being really slow to change, kind of very technology backwards. Um, and I mean, when we started the company, like that was definitely true, but I think that's really changed in the last like 1 to 2 years. We're seeing a lot of customers now being very open about the technology and actually taking more of like an approach that I would typically see at a software company, where it's like, like there's this technology, we don't know if it's going to work for everything, but let's try to figure out how to implement it and do some experimentation and actually work with the technology providers and create an implementation plan and really champion new technology being integrated. I think that's going to change a lot by 2030, where I
Mm.
think a lot of these more industrial companies are actually going to have very developed and structured ways of, okay, if there's this new technology, like this department gets it first. This is kind of like the financial structure, and this is like kind of the development structure. And they'll have like phases like, okay, we have to test here and test here, and these are kind of like expected metrics, like a very, very structured approach to deploy new technology. Because that's also, I think, one of the biggest challenges, right? Is like when it comes to software companies, like companies have like these processes of, okay, if there's this new tool, like we're going to test it out. There's these unit tests we can run, and then see if it works. Like we can measure like expected gains, like A/B testing, and you can like have like a rollout plan, right? Of like, okay, maybe we don't do whole company first, we do section by section. But that's
Mm.
really missing today from the industrial sector. Like today, like basically what it looks like is, hey, like I like this thing. Like let's try to figure out like how do we get this implemented? Maybe this works, maybe that works. Like, okay, like did fit this step, like where do we go from here? I think cleaning that up will definitely make things go a lot smoother.
And then one additional point, kind of jumping off Gary's thought right here, we are starting to see this like fundamentally change. So we just engaged with a very large shipbuilder, and they gave us a very interesting insight where they were dealing with labor shortage issues specifically in their welding department. They had posted a new position for a welder, whatever class of welding it was. And they said after 2 weeks, they had two applicants, and that was it. And this is one of the world's largest shipbuilders. So there's no shortage of eyes on the company. They then repackaged the offering and adopted robots and said robot welding technician. And they received thousands of applicants for the same exact position. But instead of actually completing the work, you're now managing something that's doing the work on your behalf. So I think we'll start seeing more companies kind of taking that approach, and it really helps quell a lot of like the acute labor pains that most companies feel right now. It's still, a position that's delivering the same outcome at the end of the day. It's just been augmented with the introduction of.
Awesome. I see. All right. Last question for both of you before we get going. What keeps you up at night? What gets you out of bed every morning? What's the hardest unsolved problem? Feel free to start us off, Gary.
I mean, that's easy. For me, it's just how do I get more robots out there? My thing every day is how do I get more robots out onto the sites? I would say like it's like for me, it's about like how do we kind of like I think when we first started, I was like, how do I build a technology? But now like that's a lot more straightforward. I think now we kind of like have very good like, you know, roadmaps of like, okay, where do the product can go? Where does it need to improve? Now it's more of a question of how do we educate the people in the industry and investors and even engineers. I think education is kind of like one of the biggest focuses because we want people to know that this is available. Like we have people where we get on first calls with them on sales where they're like, I didn't even know this was possible now. And then like they really change their thinking once they see that, this is actually making out into the world. So I think that's definitely one of the biggest things is like, how do we actually make sure that people kind of understand like what's possible, but also where the limitations of the technology are so that everybody has like, is on the same page. We have realistic expectations and we can move forward with more deployments.
Yep. Conley?
Could you ask me the question again?
So, what keeps you up at night? What gets you out of bed every morning?
Coffee.
I love it.
I actually would say my real answer here would just be genuine curiosity why things
Ah,
are the way they are. I think across all industries, all processes, across, communication gaps now within, technology to field kind of transitions.
yep,
Um, just digging in. I think that's like, I don't know, love to think about why things are the way they are. And there's been so many times where we've uncovered a process or just a meaner method of getting something done. And it might have originally seemed odd to us. And maybe there
yep.
was truth to the reasoning why it was done that way. But more often than not, you dig in and you find out it's just because that's how it's always been done. No one's actually asked the question why. Why are we doing this? So yeah, I'd say it's just a constant question in my mind of myself, what I do, my choices, but also the larger industry as well.
Well, I think I know the answer to this one, but maybe just one or two quick sentences from you guys. What does success look like for Raise Robotics and for the industry in 5 years from now?
We want 500 to 1,000 robots out there. That's one of them. I think C is where when people are going to start a new project or they're doing work, I want them to think hey, okay, we're gonna use Raise robots for this part, and that's gonna be our go-to. It's kind of the same way where it's hey, I for us, we need to machine a bracket. We're okay, we can either use a 3D printer or a CNC, sorry, not machine, but make a bracket. It's okay, we can use plastic, 3D printer, metal, CNC. It's these are our go-to tools. They're so reliable and such a common way to build things that it's just the first thing that comes to mind.
Yep. Anything to add, Conley?
I think my goal for the next 10 years, I want to obviously get more robots out. I want to be at a point of influence where we've seen a drop in the safety incidents regarding the specific scopes and applications that we've deployed in. And second to that, I want to be the first company that crosses the chasm where customers actually get an insurance benefit to deploying their systems with us. No one's done that yet. Everyone's queuing in on it. I think we're going to crack the code. We're going to figure out how many hours it takes and start saving some people money, deploying our solutions in the future.
I like it. All right. Where can people find out more about Raise Robotics?
I would say go to our LinkedIn, updating the website right now, just as a heads up. The website is raiserobotics.ai, and then our LinkedIn is just Raise Robotics.